Okay, so what we want to do here for a minute is to look at what we're going to do. The first one says use a standard access control list to block host A from accessing host B. Standard access control list, what can we do with a standard access control list?
A lot of things.
A lot of things. What goes in a standard access control list? Deny what? Exactly, deny what? Host IP address, that's it.
And allow.
Or an IP address. We could use a subnet. Yeah, permit or deny, but in this case we want to deny it. So what would the statements be? Access list, I'll give you that. What? 10? 1 to 99. Access list 10. And since we want to deny, use a standard access list to block host A from accessing host B, so we're going to deny, since it's a standard access list, we can only use the source IP address. So we're going to deny host 192.168.10.50. Let me turn this pen on here. This IP address here, right?
And since it's a host, we don't need to block the entire.
They don't need to block the entire. We can either use the wildcard mask 0.0.0.0 or the keyword host. And then after that, what do we need to do? After we do our deny, what do we need to do? Well, we have to have at least one of. I wish I had a pen. And then we have to do a permit. What are we going to permit?
The switch? No, it's the router.
What are we going to permit?
Nothing.
I would permit any, because the only one we're going after is Dustin, who's been surfing porn.
What about him?
We'll get to him in a minute.
What about that hacker over here?
Hacker, we'll get to him in a minute too.
Oh, you mean that person?
So we're going to do, it's going to be a pretty simple list, isn't it? Deny, host, 192.168.10.50, and then permit any. Where are we going to apply this access control list? On host B. We can't apply it on host B. There are several places that we could apply it. We can apply it, and you'll notice, again, this is a VLAN, VLAN 10, VLAN 20, so we have sub-interfaces up here. We could apply it right here, could we not? On the interface, in. We could apply it here on the interface out, B. We could apply it here on the interface in, or we could apply it here on the interface out.
Can you not put it in the switch? Or can that only be...
No, you can't put it in the switch. The switch is layer. What is the switch? What layer does the switch operate at? Aha, we're going to have to go back to the OSI model in networking 1, huh? I would say layer 2. Does the switch, a layer 3 switch, we could do this, but not for a standard access list. And this is where do we apply. If we applied it here, and let's say that we then put another interface here, some more resources down here. If we apply it here, what's going to happen? Can't get through, so if we put another resource down here, we couldn't get to that resource. Same effect if we did it here, right, for B. Same effect if we did it at C. If we apply it at D, and again, this is for a standard. Remember, the standard access control lists are applied closest to the destination, because you want to go to San Diego, get that suntan. Closest to the destination, and it's to prevent if there's something else that we don't deny access to that. So by putting it here, this guy can, let's see if we can change the color of this thing, ink color. If we had other stuff, it can come up here, go through this interface, and it actually comes back down since it is a VLAN, go through here, and come back down to this other resource. But when it tries to go here, it gets rejected. So hopefully that, if you think through that, the standard access list closest to the destination so that you don't inadvertently deny access to things that you don't mean to. So what we need to do here now, let me get rid of the pen. You like that pen? Let's get, wait a minute, that's not what I wanted to do. Let's discard them. Let's go to this topology, and we're going to go on router 3, right? And what we want to do here is to, I guess, go to config T first, right? And then access list, you want to use 10, that's fine. And then if we do the question mark, deny or permit, what do we want to do? We wanted to deny, and then what? Host, and it's the IP address is 192 host A to host B, right? Huh?
Instead of that, yeah, just put host A.
No, because, well, if we had a DNS server, which I don't, and we could resolve the host name.
Okay.
But we have to be able to resolve the host name if we're going to do that. In this case, I have to use the IP address because I don't have anything else to resolve it.
Isn't there a place in the router where you can actually map an IP address to the name of the router?
Yes, if we use a host file, we could do that. Or if we were using Active Directory where everything automatically gets put into DNS, we could use that DNS server to resolve them.
Active Directory is heavy.
But we don't have that situation. We haven't created a host. Host files are really cool. We have one host. What if we had 10,000 hosts?
That's where Active Directory.
That's where DNS comes in and automatic registration comes in. That's where dynamic DNS comes in. We don't have any of that stuff, okay?
That's what I've used.
Yeah, we don't have any of that stuff. So we're going to use the keyword host, and then what we're going to use the host, and after that we want the IP address, which is 192.168.10.50. And then what goes after that? CR carriage return. Okay, we have our deny statement. Now what? Permit. But we're going to have to type access. Each time you have to type this, access list 10. And then with question mark, permit. And then what do we want? We can permit any, or the host, or whatever. Permit any. Always any. And that's what I was talking about earlier. Each of the operating systems has their own vocabulary. It's just a matter of, and especially in this one, just using the question mark.
So permit any allows you to have all inbound.
All traffic. Then first of all, it's going to look to see if I am 192.168.10.50. If I am, it's going to say no. If it's not, it's going to say, come on in. The little sentry's sitting there looking at the IP headers, the TCP IP headers. And the only thing that we can filter on with the standard access list is the host IP address or the source IP address. So it's going to look at the IP address at the source IP address and only the source IP address to see if it matches. If it matches the deny statement, it's going to reject the packet. If it doesn't do that, it's going to allow us in. And we've got a couple of them that we can do here. This one's a little bit different from the drawing, is 3.2. First of all, let's see if we can ping that thing to start with. Ping 192.168.3.2. Oh, not looking good, huh? Well, it's still timing out. Wonder if I saved it wrong. Huh? I did change it to where it is the same address as in the topology that we have. So let's try 3.50. Maybe that's not going to work either, huh? Okay, we got there. And notice how this thing goes. It goes to 10.1 to 2.2, and so we can get there, and this is from host A. We wrote the access control list, right? Why didn't it work? Let's do one other thing before we go in, because we have to, once we write it, we have to apply it. Let's see if this one can get to ping 192.168.3.50. Okay, so that one's working fine. That's host C, not host A. So we wrote our access control list, and how can we do show access lists, deny host, permit any? What do we have to do now? We have to apply that access list. And where were we going to apply it? We went through all that nonsense. Let me get this out of the way. We're going to apply it on right here on this interface, right? Fast Ethernet 00. So we need to go to int fast 0/0 IP. And notice we have IP access group. Question mark. Again, use the question mark. If you take the CCNA, you can use the question mark. Practice using it. It saves an awful lot of time. Because are you going to remember all this terminology? Are you going to remember the question mark, I hope? And you see that, say, oh yeah, I got to do an access group. Access group, and then what? 1 to 199. What did we use? 10? 10. And then the question mark, in or out. And we wanted this one outbound, right? Because it's not coming into the interface. Put your arms out, it's going to be going out of the router. So this one's going to be out. And we should get the access denied. What we're going to do, let's show access lists again, and we have this, permit any, and let's go back to host A and see if we can ping 3.50. Destination host unreachable. Worked before. What about host C? Can we get there just to see that it's still up? 3.50, it works because it's not 192.168.10.50, it's 192.168.20. something.
So if you wanted to configure all the routers that way.
If we want to configure all the routers that way, and one of the other things that it does, looky here, not only does it tell us after we've tried and didn't succeed that what the access list is, it says that we had 4 matches. We have 4 matches for the deny, and we have 4 matches for the permit because the one led me through. I got the ping. We have 4 ping packets. It denied 4 ping packets for 192.168.10.50, and it permitted 4 ping packets for something else. So not only, once it's running, not only can you see the statements, see the access lists, when they're in action, you can see that they're actually working with the show access lists. I did do it, yeah, show access lists, or you can use show IP access lists, either one. When we applied it, it's IP access group. If we're going to use the named list, it's IP access list standard or extended. If we're just going to use a numbered access list, it's just access list. The reason IP and applying it is if you had some of those other protocols which are no longer available, but you still have to specify the IP portion of that. Does that make sense as we go through this, go through that particular one? I did that because James got to go here. I wanted, and we started a little bit earlier before some of you got back. This is being recorded so you can watch the whole thing if you want. To go through one of these things. The steps in it, was that really all that painful? No. The drawing looks confusing. Why does the drawing look confusing? Huh? That's not really. It's kind of a, what, this drawing's a chaotic mess? Looks like you go what?
It looked like you could have shifted router 3 and router 2 on the other side.
You could have, but this is the topology that's there.
You don't even need router 1.
Oh, we're going to. We're going to, because that's the way we get to the internet. And when we get down here to get to the internet, we're going to need that router. Because at the other end of that router is our web server that we're going to block here in a few minutes. So what does the next one say that it wants to do? Use a standard access control list to prevent host A from telnetting or SSHing to router 1. Now we need router 1. What if, see, I don't like my pen now. So what we want to do is prevent host A from telnetting to this router. What if we applied the access list on this interface Ethernet 00? Could we do that? Because that's the way it's got to get there, right? Actually, the path that I showed, where it's really going to go is up here to this router, to its interface, and back that way because we have VLANs. Remember, VLANs, that's a router on a stick. So where are we going to apply this particular one? How about on the telnet terminal? How about the VT1? Will that work? And what we want to do is to, and the reason I want to do that, remember that, you guys remember that, because when I go away I'm not going to see this. We want to prevent host A, boy we're really picking on host A, aren't we? Stop him from telnetting to router 1. Router 1, 192.168.1.1. First of all, let's go back to this thing and see if we can telnet to it right now. And this is, and again, back to the why do we need this one? For Andrew, right here is our web server, because so when we get to that extended access control list, yeah, we do need router 1. And right now we want to prevent it from connecting to this guy, and this should be 192.168.1.1, right? Let's see if we can telnet to it right now. Telnet 192.168.1.1. And I used a really complex password to do that, so I can telnet to it. Who else can telnet to it? Everybody. But we only got a bad guy on host A, because Dustin's now trying to go affect the filters that's keeping him out of the internet, because we just blocked his internet access. Easy to just. Now he wants to get in there and change the access control list. And this kind of points out, physical security is a really big deal with routers, because when you went through in the first block changing the password, what was the only thing you had to have really? You only had to have physical access. You could change the configuration register, then you could go in and change the password. So this one, and you do have to get to enable, you have to have an enable password. Otherwise, it just says that you don't have a password. So we can telnet to this thing right now. Where do we want to set this access control list? On the VTY port. But the first thing we want to do is write the access control list, right? And I had to put a password on it before telnet would work. Well, once you type it, I never can get it to go back. So I'm going to go to config T, and we're doing a standard access control list, right? Access list, what number do you want to use? We can use 10 again. We can use 20, anything, huh? 5 works for me. I guess 5 would be better with that. And then what do we want to do? We wanted to deny host A, which was what? 192.168.10.50. Actually, we needed to put, and now let's see what it says. Now we need the wildcard bits because I didn't use the host keyword. And what are we going to use? 0.0.0.0, right? Check all of the bits. 0.00 says check to be sure it's 192. Check to be sure it's 168. Check to be sure it's 10. Check to be sure it's 50. Or I could use the host keywords. To me, and it really is easier to write host. Of course, you got to remember to do that. And then, what's left? That's all we can do for this one, isn't it? Now what do we need? What if we stopped here? We denied 192.168.10.50. Did we deny 192.168.20.20 also? If we stop now, you're shaking your head no. If we stop now, because what do we have at the end of this access control list? We have an implied that you don't see an invisible deny all. So I now have two deny statements. What do I need? I have to have at least one permit statement. Otherwise, it's kind of, well, it's really not, because until you put at least one statement in and apply it, it's not there. Access list 5, permit any, right?
Couldn't you just do a WR, right?
A what? WR?
I think it's WR, isn't it?
What, right? That's just a right. You can use a WR to, that's the same as, yeah. In the older ones, that's what you, no, not to apply it. Right just saves it. If we want, and what right was used for in the past was to, instead of copy start run, or copy run start, you wrote the configuration. And you still do on some firewalls, you use the WR command.
So I was using an older.
Yeah. Yeah, the older ones, and some of the firewalls still use it. The old PICs that we had still use this. We show access list.
That's what I was using in the Army.
Yeah.
WR.
Yeah. Deny host 192.168.10.50. Now, where do we want to apply this one? We want to put it on line VTY 04, right? So config T, line VTY 04. And what are our options here? Access class. We don't have to put IP in front of this one. Access class, and what was the number? 5. Now he wanted 5. We did 5 on this, 10 on the other one, 5 on this one. And then we want to apply it in. Because if we applied it out, it wouldn't keep that user from telnetting, but it might prevent us from doing something from the router. So IP in. Now then, we should be able to go back to host A and see if we can telnet to, and it gets an immediate connection refused by remote host. Did it apply to anything else? I guess we could try this one, huh? Telnet 192.168.1.1. I can still go from the other ones. So it did work to only deny that host. Questions? So let's go back and see if we can do the extended. In this scenario, using the extended ACL access control list to prevent host A from accessing the R2 WAN link. So we can use a source and a destination, all right? So what we want to do here is, turn my pen back on maybe, is to prevent host A. We're really picking on you, Dustin, from accessing this WAN link, and this WAN link are all on the 2 network. We could use either those 2 IP addresses, or we can do the whole subnet. Let's do the whole subnet. So I guess the first thing is to see if he can ping 192.168.2.1. That would be a test to accessing it. True? Perhaps? This one I think is going to do something hopefully a little bit interesting. So where do we want to apply this? That's what we didn't do. Let's go back to this thing. Where do we want to apply this access list? Where do we want to apply this access list? This is an extended access list. Where should it be applied? Closest to the source. So where are we going to put it? This is on VLAN 10. This is on VLAN 10. Its interface is going to be Fast Ethernet 0/0.10. If we applied it here, is it going to do any of the bad stuff that the standard list did to us? Can we still get to the internet? Sure, because the only thing we've said is it can't go to, or we're going to say it can't go to 192.168.2 network. That's the only thing it won't be able to access. So extended access list we want to apply closest to the source. And now if on a layer 2 switch, no, we can't apply an IP access list there.
But Dustin can still get to his farm for the time being.
Say again?
But Dustin can still get to his
Well,
farm for the
we're going to fix him up. Now, no, not exact. Well, no, because we did that with one of the other access lists because we just used his IP address, right? See if I can get out of here. Actually. So, what should our statement say? What are we going to do? Access list, I'm going to get on the router. We're going to put it on this router, right? Config T and access list, and what number do we want to use?
2.
2 won't work. Why? Got to be even? No, because it's an extended access list. They start at 100. We can use 102. Okay, so we'll use 102. The next thing it wants is permit or deny. What we're going to do is deny, right? Deny, and then we want EIGRP, GRE, IP, or TCP. We're going to deny it that entire WAN link. If we use IP, it denies all the protocols, all the IP protocols. If we use TCP, we can be specific. So in this case, we can just use IP, right? IP, and then what we want? Any or host, so we want to deny host. And what are we? 192.168.10.50? 192.168.10.50, and then it wants the destination address. And the destination address, let's just go ahead and use that whole subnet, 192.168.2. 192.168.2.0, all right? And what are our wildcard bits going to be if we're going to use the entire Class C subnet? 0.0.0.255. It says check to see if it's 192. Check to see if it's going to 192.168. Now what it wanted after the .0? Destination wildcard bit 0.0.0.255. We could be a little more specific, but let's just go ahead and use this one. After this, the only option is carriage return. Now what do we need to do? What if we don't do anything else? If we don't do anything else, we still got to deny everything after that. So now we still need access list 102, permit, and we can use IP again, and we can use any, and we have to have a source and a destination, any. In the standard list, we only had to have any. In this one, we have to specify both the source and the destination. So, show access lists. The first one, 102. Deny IP, host 192.168.10.52, 192.168.2.0, 0.0.0.0.255, permit IP any. Before we go, let's see if host A can ping 192.168, ping 192.168.2.1, and it can, because we haven't applied the access control list yet. So now we want to go back to our router here, and what interface? Show IP interface brief. That's another great command. Fast Ethernet 0.0/0.10. That's where we want to apply this thing, right? And we want to apply it inbound so we don't have to worry about any processing on any of the routers. Does that make sense? So we should go here to config T and interface Fast Ethernet 0/0.10. 10 IP access group, and what did we use? What number did you want to use, Andrew? 10 something. You want to use 102, right? 102, 102, and then in or out. And we want to apply it in as it comes into this router. True? In. So now then, we go to host A, should we be able to ping 2.1? A destination host unreachable. Now the real question, could we get to 3.50? No? Let's see. 3.50. Host unreachable. I still got 2.2. No. From 192.168.2.2. Ping 192.168.3.1. How come I can get to 3.1? Actually, I should have been able to get to 3.50. But I can get to 3.1. Let's just try it. 3.1, which is? Now it's right here. It's this interface right here. Why can't it get there? Why can't it get there? We only blocked one specific IP range, and that was 192.168.2. This is where all of this stuff, where we want you to look at the header, do this header lab and that header lab. What's in the header? If it goes from host A to the 192.168.3, is 192.168.3 any place in our access control list? Nope. So it can get to the other end. The only thing it denied was the WAN link, which is what the problem said to do, wasn't it? This goes back to what's in the header. Does some of those labs that you had to do in networking now kind of maybe come back to, why do we have to do this stuff? Why do we need to know this? Because when you start writing these lists, knowing what you can filter on becomes really important. And when you start writing firewalls, it's an even bigger deal. So since we used the IP header, now let me see if I can find, if I can get it open. I think I put it in the cheat sheets. TCP IP header information. And it's going to be a little slow because I've got all the other stuff running on here. We go back and look at the IP header. We have the version and all this other stuff up here. We have the source and destination IP address. There's no way it gets across IP address. So since the 3 is not in the source or the destination IP address, it allows that traffic to go through. Got to pay attention, and it is always a good idea after you do these things to test them. Some people will just configure this stuff, say, oh, I know it works, and move on. Test it as a user, from where to where, to be sure it's doing what you want it to do. And we can again go back to the IP access list, and this was on router 2, right? Do show access lists. And it shows us our matches. Permit IP any, we got 16 matches because some other traffic's going on. So you can see not only what, but what's actually working on your access list. Let's do one other one, and then I'll be quiet. And you can work on labs. So let's go back to this thing. Actually, I did those, and I probably shouldn't have kept them, but I did. The next one says use an extended access control list from host A to prevent host A from accessing, this says the CBT nuggets, I put a simulated server with a web server on there. We'll look at the page here in a minute. So again, where is this access control list going to go? Since it's an extended access control list, it ought to go in the same location, shouldn't it? So that we don't have to send the packets to other places, process them, and then drop them. So we're going to apply it on Fast Ethernet 0/0/0010, right? So we need to go back to this router. Let's make this one go away. No access list. And what was it? 102. Be sure it went away. Do show access list. There's nothing there. But what didn't I undo? Do I still have that access list applied? Because I didn't go to the interface and type no IP access group in, did I? Let's see if we can cheat the system here. Let's use the same number. If I use the same number and I don't take the apply off, what's going to happen? I guess I've got 102, and we're going to deny, right? And what are we going to deny? IP. We're going to deny TCP because we're going to only deny the web server. And what? Host, right? 192.168.10.50. And before I do this, you know what I need to do? I need to check. I need to check and see if I can get there, because if I didn't take the apply off, what's going to happen as soon as I write that access list? It's going to apply it. So this guy is 6.2, okay? The server is 6.2. So let's go to host A. And what is kind of cool about this is we have a web browser. And let's see if we can go to 192.168.6.2. Is that right? So I have my little packet tracer web page. Okay? So now let's go back to router 2, 192.168 host, and then what are we going to apply? This says that we can, any destination host, destination address. What address are we going to use? 192.168.6.2. That was the, and I need to put host in front of here because I don't want to type all those zeros again. Host 192.168.6.2. We're going to deny host 192.168.10.50 access to that, but we only want to deny a specific port, right? Do the question mark again, and it says a bunch of things we do: greater than, less than, not equal to, equal to. So let's do equal, EQ, question mark, FTP, all those things, www, or the port number. We could put www, or let's just put port 80. Okay? And it said that that was good. Let's do a do show access lists, and we've denied it access to the web page. Let's see if we did. What if we go there again? What if we stop, turn that off? Should that work? 192.168.6.2. Waiting. The reason I closed it is this thing caches just like Internet Explorer does. Request timed out. But what else have I done? What if I go to host C? Should it be able to get there? Because the only thing we did was deny our 1, right? 2.168.6.2. Can it get there? Because we only denied that 1. So we've stopped the 1 and denied the other one. Honestly, I think it's something in the programming, because deny TCP host. What should be after this? Should I have to put one more statement in there? And I guess the answer is no, because why don't I have to put a permit any so that 6.2 can get there? Because, let's go back to the picture here that Andrew doesn't like. I denied it on this interface. Host C doesn't use that interface. Host C uses, this interface. It's on the .20 network. But what about everything else that was on VLAN 10? What if I put another host on there? Would it be denied? I think it would, because what goes after that statement? What do we have next? Let's go back to our router. Well, we're on router 2 here. We have an implied deny any. So what I really need to do now is go to access list 102, permit any, to permit any other hosts that might be on that network, on that subnet, to be able to get to the internet. If I don't do that, it's denied that entire subnet because of the implied deny any at the end of the access list. So I'll put that one on, and it didn't like what I did. Why didn't it like what I did? What didn't I do? I didn't give it a protocol, did I? Yeah, God has specified a protocol. TCP any TCP protocol, any IP address. That's what the TCP any means. Are there questions? You've got some exercises to do, and again, honestly, the only way that you can actually learn how to configure access control lists, I think, is to configure access control lists. Let me find the anatomy, and I'll print it and post it in the Moodle in the cheat sheets area. I've got one that's called the anatomy of an access control list. Doesn't do a whole lot more. The question mark will do as much for you. The help screen will probably do as much for you as anything else. Don't be afraid to use that. It's going to keep you straight. Don't be afraid to use the tab key. Tab key prevents an awful lot of typos. It works great, doesn't it? It took me a long time to, oh, yeah, boy, that's a lot easier, and I didn't type it wrong. And if nothing happens when you hit the tab key, you should say, I must have done something wrong. I may be in the wrong mode. I may have started it wrong. I may have a typo in here. Or I may not have gotten far enough for it to be unique. But it is something that works really well. Questions? Okay, so go ahead and work on the labs.